This video is about solving a system of equations using a graphing calculator. So because not all lines are going to have integer y-intercepts, it's sometimes difficult to find your solution of graphing. However, to make our lives simpler, we're going to use a graphing calculator to find the solution. We just need to make sure that our equations are in y equals mx plus b form. So what you're going to do first is enter the equations into y1 and y2. Then we're going to hit graph to see our picture. And then we're going to hit second, trace, choose option 5, and hit enter 3 times. So in the first problem, we have both of our equations in y equals. So in our graphing calculator, we're going to hit y equals, and we're going to clear out anything that might be in here, and we're going to type our equation. So the first equation is y equals 1. And the second equation, when I arrow down, I need parentheses because it's got a fraction. So parenthesis 3 divided by 2, close parenthesis x, plus 6. After we have both equations in, we're going to hit graph, and we see a picture. So we see our picture with the lines intersecting. So we're going to draw a quick sketch of that. So we have one line that is horizontal, and then we have another line that's increasing from left to right, and they're intersecting somewhere in the second quadrant. So to find that point of intersection, we would hit second, trace. It will take us to a menu that says calculate. We want to find the intersection, so we're going to pick option 5. It will take us back to our graph, but now we have this blinking cursor. We're going to hit enter 3 times. 1, 2, 3. It should say intersection at the bottom, so our intersection point is negative 7.5 comma 1. So at the intersection, we put negative 7.5 comma 1. And that's going to be our solution, negative 7.5 comma 1. In number 2, we have y equals 5 over 2x plus 1. And we have y equals negative x minus 1. So in y equals, we're going to clear out our equations. And in y1, we're going to type our equation. So in y1, we have parenthesis 5 divided by 2, close parenthesis x, plus 1. And in y2, make sure, because this is a negative x, we should have a negative in front of it. So negative sign, not a subtraction sign, negative x minus 1. So you know you have the right one for the negative sign because it's a little shorter than the subtraction sign. Once we have both lines in there, we hit graph. Again, we see our lines intersecting, so we're going to draw a picture. So here's our lines intersecting. And that is our intersection point. So now to find the intersection point, second, trace, option 5, hit enter 3 times. We have to round this. So the first one rounds to negative 0.57, and the next one rounds to negative 0.43. So we have negative 0.57 and negative 0.43. In our next one, we have one equation in y equals and one is not. So the second equation, we need to solve to get this in y equals first. So we're going to add 2x to both sides. Negative y equals 2x minus 7. Then we're going to divide everything by negative 1. So y equals negative 2x plus 7. So we're going to use these two equations in our calculator then. So in y equals, clear out what we have. The first equation, parenthesis, negative 3 divided by 4, x plus 4. The second equation we had was negative 2x plus 7. So we're going to hit graph. We see our intersection. So we have our two lines going down from left to right. One is steeper than the other. And we have our intersection point. So to find that again, second, trace, option 5, enter, enter, enter. So that'd be 2.4 comma 2.2. So our solution is 2.4 comma 2.2. In our next problem, neither of these is in y equals, so we're going to have to get them both in y equals first. So the first equation is 3x plus y equals -2. We can subtract 3x. Y equals -3x minus 2. Our second equation, 6x plus 2y equals 10. We can subtract 6x. 2y equals -6x plus 10. We can divide by 2. Y equals -3x plus 5. So in y equals, we're going to enter our equations. -3x minus 2 and -3x plus 5. When we hit graph, we might already have noticed what's going to happen. They have the same slope, so our lines are going to be parallel. So we're not going to need to use the second trace 5, enter, enter, enter. Because these are parallel lines, it's a special case, so we know that this is no solution. So we should not have an intersection point here. Let's try one more. In number 5, we have -2x plus y equals 3. We have -4x plus 2y equals 6. So in the first equation, I'm going to add 2x to both sides. Y equals 2x plus 3. Our second equation, we can add 4x to both sides. 2y equals 4x plus 6. Divide everything by 2. Y equals 2x plus 3. You might notice they're the same equation. So if we enter them in, 2x plus 3 and 2x plus 3, when we graph this, we see that the lines are overlapping. And this is our other special case, infinitely many solutions.